Good morning, everybody, our audience who is here with us on a Sunday morning. Thank you for joining us. Yeah, taking out time on a Sunday. That shows your passion for the whole concept of agility and especially to learn something new about agile in hardware. And I will not waste too much time. I will want to hand over it to our speakers. Thank you for being here with us, Ayala and Nathan. Nathan is the group leader for neural network acceleration at Samsung Semiconductor, based out of Israel R&D Center. Welcome, Nathan. Ayala Makmel. She's the program management director at Cadence Design Systems, and she's also based out of Israel in Tel Aviv. So without much wasting too much time, I know you guys are here to hear out Nathan and Ayala, so I'll hand it over to them. And looking forward to your wonderful session here, Nathan and Ayala. As we had discussed in the earlier, folks, please post your questions in the Q&A box. I will be moderating with Nathan and Ayala towards the end of the session. But what Nathan and Ayala also have given a freedom for us is if you have specific question at a specific slide, they're okay to take it up as and when the slide questions come up. So don't hesitate to wait till the end of the event. Please go ahead and post your questions. We look forward for a very, very interesting interactive session here, not a monologue or a dialogue between Nathan and Ayala. So welcome, Nathan, Ayala. Handing over to you the whole screen.
Okay, thank you. All right, go ahead, Nathan.
So, Padma, thank you for the introduction and thank you for the invitation. So my name is Nathan and I'm in charge of neural network accelerations for Samsung. So this is chip design and we'll talk about it in a little bit. Nice to meet you all.
And I'm Ayala. I'm a program management director at Cadence, working with a verification product group. Very happy to be here as well. Thank you for the invitation. Nathan and I set on this journey just a bit before COVID started, actually. We realized we have a shared passion for this topic. We were very curious about Agile in hardware, and we set up a community in Israel on LinkedIn with a mission to learn from hardware developers about how they are successfully deploying agile practices in hardware development. We really wanted to hear from people close in our community and learn from them what they're doing and not just about theoretical practices.
Okay, so let's put the groundwork on what is hardware and what do we understand by that word. So first of all, and that's a question that comes up all the time, which kind of hardware? Because many things can be described as hardware. We're going to focus on chip design. There's a very big chip design industry in Israel, and so there's a big pool of people to draw from, and we are sometimes going a little bit beyond that, for example, for board design, but let's focus for this discussion on chip design. So what is that? The goal is to produce a chip. A chip is basically a bunch of transistors who do a certain function, and or actually a set of functions, and they're printed in a very big, very expensive factory called a fab. And that's what we want to produce at the end of the day. It starts from code, high-level code, which is RTL, Verilog. There are many different kinds of languages, and basically it defines the behavior of the chip. Not only what happens to the data, but also its timing. It describes the timing, what happens at each clock of the process. Once you've written that code, there is a very complicated process, multi-stage process to make this transistor map. It includes, of course, verification, but there are also many kinds of sign-off tools which check. It's kind of the equivalent of static and dynamic analysis in software, but it also checks things related to the process of printing the chip. It checks that there's not going to be something happening in the middle that's going to make it not possible. And there are many synthesis. It's called synthesis. It's the process to actually produce this transistor map, and I'm very much simplifying here because it's much more complicated than that. It's not push of a button, it's actually people whose job is to make it happen. We also want to be aware of power. Power consumption is very important for silicon. And again, a lot of things I'm going very fast about, but it's a very complicated process. It's also very expensive. So there is a very big cost to errors in the RTL, because then all those people who've worked, including running the fab, which is very expensive, this is a very expensive process. One of the things which we see a lot in all those companies which are dealing with chip design is that it's very, very multidisciplinary. So of course, you have digital design, which is the people who actually write the RTL, but you also have a separate discipline, which is digital verification. They produce what's called a test bench, which is the verification environment for the design. There's also often architecture people involved who look at the things from maybe a higher systemic point of view. A lot of time you also have algorithm engineers when those functions or part of those functions that the chip has to fulfill are based on algorithms. So for example, I deal with neural networks. So there's a lot of algorithms involved, but there are many other examples, image processing, communication, whether it's cellular or Wi-Fi and stuff like that. Many examples, I'm probably forgetting a lot, include algorithms. There's also often this chip includes, for example, a CPU, which is printed together with the rest of the logic. So there's software running on top of this CPU, and if there isn't a CPU, there's some other kind. So basically, at the end of the day, software is usually running on top of that chip, and it's usually involved at the very earliest stage. The more advanced companies actually write the software and the hardware at the same time to verify everything together. And to do so, all those very complicated processes require a lot of infrastructure. So there's a very strong basis of infrastructures. Maybe at this point, since this is going to be the base of all we're going to talk about afterwards, maybe Padma, is there any question on the Q&A that you think we should answer at this stage?
Not yet. No, Nathan. Nothing yet.
Okay.
Let's keep going.
So, okay. Thank you.
Okay. So, thanks, Nathan, for presenting a short introduction to what hardware development is. And now you'll come and ask, as most of this forum is probably very aware of software development, how is hardware development different? Let's start with what's similar. What is similar is code is involved. Hardware does start as code, as Nathan presented, different languages, but still code. There are functional and non-functional requirements. For the non-functional, Nathan just described the power requirements. There can be performance requirements and so on. Very similar to software, there are non-functional requirements as well. Architecture is important in both. I'll dare to say it's even more important in hardware, but both dogmas do require a good architecture in place, and testing is important as well in both of them. But there are differences where hardware is different from software development. The first one is it's harder to make changes, or it will take more time to make changes. In hardware, the cycles of making a code change and seeing the impact of it, if you compare it to software, in software, sometimes within seconds or minutes, you will see the impact of your change. You'll be able to submit your code or regress it and see the impact of your changes. In hardware, this could take days, weeks, sometimes even months to see the impact of your code change. So it's a very different time scale. Another difference that Nathan highlighted already is the number of disciplines involved. A lot of times in software, if you talk about a software development team, you're talking about R&D and validation, and that's the team. Maybe, okay, architect put inside, but that's it. in hardware, we have all these functions Nathan mentioned. Some companies, we talk even about physicists and mechanical engineers getting involved. So you need to tie all the different people from different disciplines to develop this, and not just, core software development. Another change is the cost in software to produce your software. It's, just clicking a button and running a build. Maybe you pay some money to a SaaS provider or to the build provider, but that's it. In hardware, it's many, many times more. It's real physical manufacturing in the fabs, as Nathan described. Because it takes so much time to make changes, it's very difficult to change the architecture over time. So think about software, where we talk about these practices of continuous refactoring and improving the architecture. That's really, really hard to do in hardware. If you don't have the right architecture up front, it's very hard to change it down the line during the project. And because of this, and because it's a physical product, it's impossible to refactor the product once it's been manufactured. If you remember those Samsung phones that got hot, once it's out, it's out. You can't fix it. In software, if you have a bug, you can just push another release if it's on the cloud, and very quickly all the customers get that fix. So while there are a lot of similarities, there are a lot of differences between hardware and software development. Any questions before we proceed?
Let's go ahead. I think people want to see a couple of more slides.
Okay.
Okay, so when we started, we didn't really know what we wanted to do, so we started with the round table, and we were pretty happy to see that there is an interest around the subject. We saw something like 80% participants, which was a good surprise for us. So as I mentioned, there's a lot of similarities and differences between software and hardware. And basically, you have to be aware of that when applying Agile. And for me, it was eye-opening because I was kind of like on a cloud. I was thinking, yeah, it's code, you can do everything the same. And the first roundtable really put the emphasis on what is common and what is different. And I think the bottom line is that what is common is the mindset. Agile mindset is not about, in my opinion, ceremonies. It's about spirit. It's about spirit that you have issues in life, you want to solve them. You want to understand what is valuable for you to invest effort, time, money into solving. So you want to identify the problem you want to solve. And then you try it by trial and error. And maybe that's agile on one foot, if you will. To drill down further, we did see some agile concepts, more detailed concepts that work very well for hardware. Improve communication and visibility. It's one of the basic paradigms of agile that people have to, how is it said in the manifesto, improve people communication over processes. So that's also very important in hardware in particular because of the multidisciplinary style that we've seen. So communication can be even more challenging in hardware. Irregular delivery of value through milestones or sprints is also very important for hardware as in software, because well, for many reasons, for the same reasons as software, the timeline may be not exactly the same, but instead of waiting 2 years to deliver something, if you manage to deliver value at earlier, then you have a better chance to fit what you need to achieve. And the third point that we really thought works well all across the board is definition of done. This very strong emphasis on expectations between the customer or the product who represents them, and on the other hand, the people who are going to do the implementation. So the better the expectations between those two functions at the beginning of before development, the more you will have something that fits the needs at the end of the development. On the other hand, we did see points for which it doesn't transfer as well. So we talked about the importance of regular milestones, but those milestones cannot be as short as in software. As Ayala mentioned, hardware usually takes a bit more time. So we usually see slightly longer iterations. And maybe that's the most anti-agile thing. One of the tenets of agile is cross-functional team. You want to have two pizza team of no more than 10 people who basically can do everything from beginning to end to produce value alone. So that's why in software you'll very often have development and QA in the same team. In hardware, it doesn't work. I want to say from a personal point of view, I did try it. It was a disaster because maybe so many disciplines are involved. So first of all, if you want to have, I don't know, two people from each disciplines, you already have more than two pizzas. And maybe also because those teams, those functions are not exactly working in the same way, in the same culture, in the same spirit. So you have to find other ways, some kind of scaled agile to do the cross-functional cooperation.
Nathan and Ayala, there are a couple of questions. Actually, one on the previous. I think my net was a little slow, so all the questions downloaded at once now. So
Okay.
one, the question is how long or what is the duration of the process from code to printing the FAB, the fab that you spoke about in the previous slide?
I would say month once the code is closed. Ayala, please correct me if you have another, but I would say 3 to 4 months until you get the chip out of the fab, and then maybe another half a month to see it working, to see some kind of hello world from the chip. Ayala, do you think it's more or less the rough estimation?
Yeah, roughly, yeah. And if we look at the overall cycle, we're talking the whole these projects, they're like, they depends on the company, but they can be 2 years. They could be 1 year if it's a company that's running really, really fast. But these are multi-year projects from the start of the architecture and until the end of the cycle, those last few months of actual physical production.
Thank you. Thank you both. There is one more question. Ali from Netherlands. Good morning, Ali. With
Good
respect to
morning.
IC development, I would love to know what your view is on iterative development post tape out, as lots of stuff is simulatable pre-tape out. So I wonder what your views on iterative V&V of a physical product.
So I just want to make sure I understood the question. You're not talking about iterating pre-tape out. You're talking of on simulation platforms. You're talking about iterating post-tape out.
Yes,
That's
that's
correct?
what Ali is asking for. He's asking your thoughts and views on post tape out, iterative development in post tape out.
Uh, so from my point of view, it's basically a question of money because iterating post tape out costs money. So you have many different kinds of things that you can change post tape out. You have several grades of changes. So for example, so the chip is composed of layers. So you can change only the last layer. It's called metal ECO, and it costs less money, but the changes that you can make are smaller. And then you have the various stages of ECOs you can do. And again, it all comes down to how much money it's going to cost. So the pressure from management is to get it right at the first time. And then if you don't, then you can change, but it's not going to look good. Depending on the chips and the products and the novelty, some chips are all from the start designed to be done in 2 steps. We call it EVT. We have EVT0 and EVT1, and sometimes from the start we know that we're going to do 2 of those, so 2 iterations. But that's only for novel chips. Some chips which are not novel enough to justify it will not have that process.
And I'll just say again, taking the analogy to the software world, we all know these diagrams about the cost of a bug when you find it at the customer versus when you find it before versus when the developer finds it as he's coding, all these diagrams about the cost. In hardware, if you think about it, it's so many times more this difference in cost. So yes, as Nathan described, for some cases you can continue to simulate and validate, and you do that post the tape out. The cost of that is big, and if you do that in early stages, you reduce the cost and the risk of the project significantly.
I would add maybe one of the skills that architects must have is to design the system, which includes hardware and software, so that it's possible to continue iterating in software after the chip is done. So we're going to let open a lot of options that we don't think are going to be useful, but we still put them anyway, just in case we have to continue iterating in software afterwards.
It's actually interesting to know because software world works a little so differently with this. Thank you. Couple of new things for me as well. One question on this particular slide as well, Agile in Hardware Israel. How can we participate, Nathan and Ayala? Like we would like to be part of the group and learn from a lot of things happening in this group as a knowledge sharing. So how can we? Maybe even if you could uh, send us a link or something at the end of the event, we could circulate it with our participants.
Sure, no problem. It's a LinkedIn group. So we'll share the link. Also, there are recordings of those meetings that we've had on YouTube. So I think the links are in the group, right?
Yeah.
But anyway, maybe we can share them afterwards again. Yeah, the more the merrier.
That's a great thing. We will circulate. I'll look for the right link and circulate it with our participants. I think we can move on to the next one.
Okay, and just to say that actually this presentation is summarizing everything that we have seen and learned so far, as you'll see in the next slides.
We can see that each slide has so much content there. Actually, we can debate on each slide itself for about 30 minutes each.
Nathan, do you want to say a word about the last bullet?
Oh, yeah, right. So at the end of the roundtable, we sort of did a retro on what's important. And so first of all, we found that people are really interested in real examples because there's some kind of reluctance from hardware designers to accept the word of software designers that Agile is great. So they want to see people actually doing it in the trenches and not talking about it. And at the beginning, we thought that maybe tools would be an important part, but we found that there's little interest and people are more interested in processes. And I think it goes well with the spirit of what we ended up to do because at the end of the day, it talks more about collaboration and how to manage humans than to manage tools. So I kind of like that.
Okay, so that was our first meetup, and as Nathan said, we had an interesting retrospective after that, and we came to those conclusions of where we want to focus our discussion. Do we bring consultants, or do we bring actual people that have done the practices? And we said, yes, we need more real life examples. And we set our second meetup to hear two focused micro talks, 20 minutes each. The first one from Edith Veron, System Engineering Manager at Applied Materials, and the second one was by Nathan about his experience with his team about deploying agile practices. From Edith, what we learned about Applied Materials experience, it was a very interesting session. Edith talked about what they took from Agile and what they kept from Waterfall, about this mesh of which practices worked well for them and which practices had worked well before, and they wanted to make sure they did not lose. And it's a very interesting and wise combination, I would say, that they did. So from the Agile, what they took is they split the project into phases. And they did do initial architecture and high-level planning, but they kept it high-level and not detailed. Where in the past they used to do a full-fledged planning, months of planning. Now they did some planning, but then they kept the detailed planning for phase by phase. So only once starting the next phase, they would do the incremental design and implementation of that phase. So that was new to them and is very agilic. Other things that they took from Agile is fixing the release dates, but shifting the content per the risks and updates in the program, where before things were different. The phases were always defined by the content and the dates could shift. And they defined for each phase a minimum viable product, which was very helpful for risk reduction. What they did keep from Waterfall was the focus on documentation, documenting the architecture and the product itself for the next project, for the current project, and for the next projects as well. They were very concerned that Agile means no documentation and so on, and they made sure that they keep documenting their projects well. They still keep doing long-term high-level planning at the beginning of the project. That is very important for risk management and for defining and planning the project correctly. They just stop at some level of detail where in the past they used to do it very detailed. And of course, they do, as all hardware companies need to do at the end on the final product, there are certain tests you do only then and you cannot do before. Edie described very nicely how they do their mixed agile planning. This is an overall process of a project, which starts with a kickoff, and then there is high-level design and effort estimation of the project. And then they go in this middle bubble into iterative work. There is detailed design and development per phase, and they work in 3-week sprints, which is actually very impressive for a hardware company. They're doing backlog grooming and PI planning and so on. And every phase goes through a more agile kind of process. And once that development is done and all the phases are done, the product goes into a beta phase. That's the kind of testing that you can only do once you have a final product, and then it goes into final design and review, and then the project is complete.
Okay, and then the second talk, which I'll summarize.
I had a couple
Yeah.
of questions on the previous slide, Ayala. Sorry. I have two questions. I think I'll club them. They look the same. What type of agile practices? You said that some of the principles and other things you have adopted already, but specifically, what other agile practices have helped you in this journey? And any specific framework like a Scrum or Kanban you have used? And if you have used Scrum, what is your usual sprint duration, which includes all events? Or do you have a customized framework that you just want to help us understand? That's, I think, one question on the process part.
Okay, so we'll talk about the customized process part in a few slides, and actually we don't see that being good fit customized processes. I'll give a sneak preview. We'll talk about that a bit more when we get to that slide.
Wonderful.
The previous question was about practices that they took. So keep in sync, because in this slide, in the next slide, and even in the following, we'll talk more. This slide, we talked about what worked for them, which is fixing the release dates and working and doing planning per detailed planning per sprint. This is, to me, was the nicest thing from here. Very aligned also with the things that I have learned even in software, that it's good to do exactly the same. All these recommendations here, actually excellent for software as well, in my opinion. And there will be more recommendations in the coming slides. So
thank you. We'll wait for that. Thank you. Yeah, we can move on.
Okay, so the things I presented during this talk was about what is called in the Agile literature the elephant carpaccio. For those who are not familiar with the elephant carpaccio, it's about how do you eat a big thing like an elephant, but in vertical slices? So basically, you want to deliver a product and you want to do vertical, thin slices of incremental values as much as possible. When involving the multidisciplinary issues that we have with hardware, and maybe that relates to what we discussed before about that the multidisciplinary connection has to be done at scale. So here's how we do it. We use initiatives. For those who are familiar with Jira, I think it's in portfolio. Initiatives are above Epic. And those are for us multi-team, multidisciplinary activities delivering value. In our drawing, the initiatives are tilted in time because oftentimes, in Agile, there's this swarming concept that everybody is going to go together at the same time on the same issue, solve it, and go to the next ones, which I love, but which not always is possible when you have multidisciplinary activities. So you have to have some tilt in time. We are not able to all the time have completely vertical initiatives. Sometimes we are able to deliver value, but not involve all the teams. Otherwise, it would be too large. So we have the initiatives delivering value, but not fully vertical. The benefits that we have is that the value is delivered often. So this is very positive in all kind of synchronization between everyone. And yes, we manage to deliver value often at each initiative. There is a clear definition of done which delivers value, and we'll talk about that. The integration between teams, which is one of the big risk points, it's done for each initiative. So all the teams which are involved in the same initiatives have some integration together, and it reduces the risk of the integration. And in terms of pivot, which is very important, one of the claim to fame of Agile is to manage the fact that reality changes all the time and you have to pivot all the time. So after each initiative, we are able to pivot at least the teams which were involved. So if we want to do a pivot, then it's getting easier than if we weren't doing that at all. In terms of what value do we deliver? So it all goes down to the definition of done. So here are some examples of definition of done that we use for initiatives. So it can be test pass over RTL simulation or Palladium. So for those who are not familiar, the RTL can be simulated. You can kind of run it as if the chip was working. It can be either done by software, fully software, or by using big machines, which are like big FPGAs. Ayala is much better at that than me. So if I'm saying things which are not exact, please correct me. And you want to have a test which passes. You have an expected result and you get the result simulated and you see it's the same, so you're happy about that. It can be digital verification, coverage. Coverage is sort of like coverage in software. You want to cover as much codes, branches, options as possible. Synthesis, which is part of the process, it's the first step of the process of going to the fab. So if you have that working, then also it's a good value to have. It can also be algorithm evaluation. It can be something delivered to customer, which is always valuable. So those are examples of value.
Okay. So those were our meetups so far. We're already baking our next meetup. And Nathan and I kind of summarized what we've learned so far from a topic perspective. So the first one is on the adoption process. We were very intrigued with this process. It seemed very natural to us to try and implement Agile in hardware, but we learned there isn't a buzz in the hardware development industry on this topic. The interest that we show is probably more unique. Yes, there are other evangelists, but unlike in software where one can say today that Agile is very dominant, not so much in hardware. And because of that, and also because it's probably the right way to do Agile deployment, you need to focus on solving some pain point. This is always going to be true. And if some company does not have a pain point, there's nothing to talk about. But there's always a pain point, right? So you just need to figure out what it is and then find out how to solve that with small steps and creating winning stories using concepts from Agile development methodology. There was a question about the structured working models, Scrum, Safe, Less, which is slightly less structured, but still structured. We find that these are not a good fit for hardware. I'll say my assumption is, first, in general, I don't like frameworks that are too stringent. In general, I think that there are always companies that need their adjustments. Every company needs its own adjustment. But think about hardware development. We've tried to describe how much different it is from software. These are models that were fit or defined for software. So upfront, they're not a good match. And they're great concepts to take from each of these. But which concept to take and implement, that will depend on the company you're working on and what challenges or what problems or pains you're having. There's good structure already in hardware development process. Don't throw that away. Keep what's working for you. If Deep from Applied Materials talked about the documentation process being very important to them, they didn't want to lose it. They made sure that they kept that. So again, all these points are connecting with each other. If you're taking a structured working model and you're just saying, okay, I'll just work like that and I'll throw everything else that I did before, that won't work well for you. And you need to make sure that you're changing just what you need to change and improving incrementally over time your processes. And the last point, which I thought was a great summary by Nathan, is let's not talk about agile development methodology and how perfect it is and how we want to apply it for hardware. Talk about the fact that there are modern management methodologies out there, concepts like improving communication, reducing risks, and so on, and that those can be applied to solve specific problems in your company.
So the second part of our summary is about communication. We've found it very like a recurring theme across the different people we've talked with. Traditionally, hardware engineers work alone. They have their own block or a part or function, and here the agile methodologies can really help to increase communication. So we've seen adoption of stand-up meetings, usually not daily. I think this goes back to the path of development. I don't think people find that daily meetings are valuable enough, that people are enough to update every day, but we do see a lot of stand-up meetings, usually bi-weekly or weekly. Mutual code review, also something which maybe wasn't so present. Maybe code review was done by team leader or technical leader or something. But we see more and more mutual code review peer-to-peer, which can improve the quality of the code, the mutual understanding of one another. Everyone understands better what other people are doing, gets the big pictures in a better way, and people get better at code even when they review, because not only by getting reviewed, you get better at coding, but also by reviewing. And also architecture review, we see a lot of better communication between architecture and design. If some companies have more separation of the architectures on the one hand, which are sometimes called in a very demeaning way ivory tower architects, and I don't agree with that framing, but it's out there, and we see much more contact between architecture and design, which we find positive.
There is one question. Maybe I'll give a few more minutes for you to probably conclude. But in this slide, I think that you have answered pretty much part of the question, which was about even in software, we end up having silo teams a lot of times, and agile practices help us to increase communication between them. So you kind of answered that question, Nathan, in this summary. But the second part to that question is, we also encourage our team members to learn other skills specifically from what other team members are doing, so that we can leverage them when some team member is not really around. But so how difficult or easy it is for upskilling or reskilling within an agile team to learn something else, because these sometimes end up being a very niche skill, and maybe team members are not interested in learning what someone else is doing also. So one first part of the question is how difficult or easy it is for us to do that skilling. And second thing is how difficult or easy it is for you to encourage your team members to come out of the silos and communicate often, communicate extensively with other team members. These are part of the same question from here.
Yeah, no, it's a great question. It's so great that we actually have a slide about that. Breaking silo is definitely completely super important. Maybe we'll get back to that on that slide if that's okay for you.
One more question there is on the practice itself, as we are summarizing on the practice. In software, we have taken up the approach of shift left, which means we test as early as possible, as you know. And so, is this something you're following, especially in the ETL code that you mentioned, because it's a code piece, and so do you test it as early as possible, or even do test driven there, so that we are early enough to find anything that we want to, or code only as much required? Is this something that from a software that we are following, you're doing it as well for yourselves?
So in general, companies across the industry, they're absolutely doing this, again, especially because of the cost. There are many, many levels. There are concepts of unit testing for these hardware languages. As Nathan described, there is simulation, which is a daily regression that's running. You develop tests and you continuously run them on the latest code. There's these boxes, the Palladium machines that you can actually run to emulate very, very fast. Some companies I actually know are using that for continuous integration flow, because these boxes run very fast. You could run it on every submit just before you're inserting it into the main line. So yes, a lot of these companies are doing these various things. And yet, keep in mind, it's much harder than software. It's much more costly than software. Developing the test, as Nathan described, it's a different skill set. It's much bigger than the difference between just R&D and QA and software. To be a verification engineer is a whole other skill set in itself. They need to learn a lot of things. So there is an attempt to do all of these things. There are tools to do all these things, and yet it's very, very hard, and it's still not at the same scale of software.
Understood. Yeah. And there's one more question related to the same summary slide. Ayala, you mentioned that Scrum, Safe are all too structured and may not be really a great fit for hardware development. We agree. Too prescriptive. But how about something like a Kanban, which is a bit more open-ended? This question is from Anant, and uh, Kanban, given it's a little more open-ended, what has been your experience of applying Kanban practices?
So I can't talk specifically of any specific company that I heard, and Kanban was the key pivot in that example, but we've just started our work, and I'm sure we will find it. Maybe actually there is the upcoming a meetup that we're working on, where one of the key elements, this is a colleague of Nathan's from Samsung, one of the key elements he shows there is visibility, where he's displaying what is going on, who is working on what. It's not a Kanban board, but it's the same concept. So what I want to say to this question, excellent question. Kanban could solve some communication and visibility problems, I'm sure, at many companies. And there are other agile practices, even ideas from SAFe, from Less, from Scrum, that we can pick up and take to help improve the development process of hardware. Just not the whole framework as a take it, implement it, find me the roles, who owns this, who is the super product owner, all of these things, very perspective. That part of the solution is not good, but each of these frameworks has excellent ideas and concepts which you can apply, and you should apply. And Kanban being one of these things, definitely a great tool to improve visibility and reduce the work in progress, right? So yes.
I think I'll go back to highlighting your sentence in that same summary slide. Do what works for you, right? I think you have said that there. I think that's the right approach. Thank you. Yeah, back to you guys.
Okay. So we talked
So,
a bit in the. Go ahead.
sorry. So yeah, short integrations. So as we say, short integrations are a good tool to deliver value more often, to reduce the risk, to be able to pivot more often. They're very challenging in hardware. We found that they're very challenging. There's a big overhead for short integrations, in particular because of the long times for development. It's hard to refactor. We do believe that we need to challenge ourselves. There is a limit to how short iterations can be, but it's not a reason not to try. We definitely should try and find that limit, and I think there is a resistance, a friction of we do what we're used to do. So I personally, I'm in favor of trying to challenge people to come up with new ways and innovative ways to do shorter integrations. One of the points is that not all part of the process are suitable. And sometimes there are parts of the process, like what we saw in applied material, which are not suitable to that. And once you accept that some parts of the process are more suited to that and some part of the process aren't, you can focus on those parts which are more suitable and do better.
Nathan, maybe you want to take this one as well.
Okay, sure. So yeah, breaking silos and try to also address the question that was asked before. So it is one of the big values that we've seen people get from Agile. The multidisciplinary work, as we've said multiple times, is very critical. And so one thing that we haven't seen, as we've discussed, is multidisciplinary permanent teams. We haven't seen that. We do see a lot of collaboration improved by ad hoc forums per vertical. So a vertical can be a task force, it can be an initiative in my case, it can be a squad using the names from Spotify. And I think it goes back to the question that was asked, how do we do communication between silos? Well, the answer is we have forums. It can be weekly meetings, it can be maybe written. Sometimes when it's less alive, it can be just by email. One of the things that we see is that those verticals, those task force or initiative or squads we've discussed before, some part of the process go well with Agile, and some part of the process maybe less. So here's the same. Sometimes you have verticals which are going to be not very active for a while and then get very, very active. So we're going to want to meet 2 times a week. And then once the peak is over, we're going to want to meet less. And I think the part of the question was, how do people take it? I think people are happy. People are happy to see the big pictures. There is some kind of reluctance to go to more meetings, but they see how valuable those meetings are. They see how much time was saved by a meeting, how much, if I have a problem and I'm not talking about it with my peer in another team, in another discipline, I'm going to try and solve it, and it's going to be very hard. And I discuss that with my peer, and wow, they have the solution very easily in their side. So they see how much value and how much time to save. So I would say that the feedback is very positive. Another thing that we have to break silos is to empower people on the ground, in the trenches, to manage those cross-functional integrations. So we have either engineers or first-line managers who are like small scale project managers and who manage these activities, and we see a lot of values in that. First of all, because they make better decisions because they know the technical issues, and second, they better understand the importance, how critical it is to be multidisciplinary, how critical it is to break silos. Padma, did I answer the question, or is there some parts of the question which I didn't answer?
Uh, quite a few answered. There is one question that I have. You're talking about cross-functional collaborations and other things, which I am assuming there will be dependencies because there is a cross collaboration happening here. While some part of it you answered, Nathan and Ayala, but anything that specifically how you manage dependencies, especially from external teams that you have no control over, and how do you do the stakeholder and collaboration management there?
Okay, so I hear two questions here. One question which is about how do we manage dependencies, both inside things which are in our control and outside of control. And second,
Yes,
how do we manage communication with stakeholders? Is that correct?
yes, yes.
Okay. So about the first part about the dependencies, inside what is in our control, we do that with those cross-functional forums, which can be more slow, low heat by emails every once in a while, or more like meetings twice a week when it gets more intense. For what about outside our control, I would say in my experience, what helps a lot is a process of looking ahead of what's going to happen and making sure that you're going to get in the literature it's called definition of ready. You have definition of done and you have definition of ready. So what needs to happen before we can start to do something? One of the processes that we use is let's look ahead, maybe a month over the horizon. Let's look at what we're going to do then. And then let's make sure that everybody who needs to do something before we can start is aware of that. And let's synchronize between us. Regarding the stakeholders, so they're the stakeholders which are input stakeholders, which we've discussed. And regarding the output stakeholders, so I would say communication, and then maybe more communication. We invite them to all those cross-functional forums. We want to make sure that they feel heard. So we have special forums for stakeholders where they have, this is the occasion when they can voice everything that they have to, and they also hear each other. I usually find that stakeholders have opposing and contradicting needs. So it's good if stakeholders A hears what stakeholders B have to say, because then they understand the constraints. And it's also communication about the planning. So if we plan ahead, then we want to make sure that we show the planning, explain what we're doing, explain why things take time, and hold our promises. I think there's a trust issue that has to be addressed. If we consistently show that we function in a way that they can understand and predict, then they trust us.
Those are really great recommendations. Actually, we should put them down, Nathan.
Yeah, I think the slide on that is worth it. That's what I was exactly thinking.
I will add one thing from my experience, and this is even from the software world and not the hardware. When we talk about the teams outside what we can control, making sure that there is management alignment up front. On as Nathan said, as we plan ahead and we know that we will need to involve them in the next month, let's say, when they are out of the control of the team and they're not working in the same process, then making sure with management that there is a strategic alignment about the involvement, that their priorities are aligned. That is very critical.
Thanks for that, Ayala. So I think maybe we have time for one last question quickly, unless you guys have anything to summarize or conclude.
This was actually our last slide, so it's a good time
Okay.
for a summary question. Yeah.
Yeah, I think it's we have 4 more minutes. So one quick question: what would be as thought leaders from this industry? What are you looking at as a future for Agile in hardware? What are the things you are expecting to change drastically from your visionary leadership that you bring in this space? How does future for Agile in hardware look like?
You want to go first, Nathan?
First of all, thank you. I hadn't thought about the thought leader, but I guess what I like to see is people doing what's right for them, regardless of inertia and preconceptions and paradigms. So I wish to see, I don't think that agile is a religion. I don't wish to see people doing more agile. I wish to see people doing more what really is good for them after they've tried it and they really know that if they're not doing something, it's because it's not good for them. And if something is good for them, they're doing it.
I agree on that. I will say that as we were preparing for this and presenting this right now, um, I think there is room, Safe and Scrum and all of these, they developed because there was a need for a paradigm. And I think there is room not to define a framework, but to do more work like this and see what are recommended best practices that typically do help hardware development companies improve their processes and put a spotlight on those and improve the um, communication and visibility of these practices in the industry. I think it's still in early days. I think, as we said, there's a lot of resistance and there's no buzz. I think as an evangelist of process improvement and being an industrial engineer, I think there is a lot to do here, and I think companies have this need, especially as they scale and grow. So I think giving more visibility to those things will help. Nathan and I, when we set on this process, we did some reading up and we tried to look for good references. We found some references about Agile and hardware, but they were very technical, actually, focusing more kind of on the how do you do unit tests and hardware and things like that, and less on the things that we talked about here. And I think we're learning these over time and maybe externalizing them more and more sharing with companies across the world. That would be good.
Yeah, definitely agree on that.
Absolutely, Ayala. I also don't see a need for another framework. We have a lot of them already. I think what I hear from you and what I'm learning from this specific session itself is that I think communities have to come together, share the best practices. A lot of cross pollination should happen between what we learn and what we can give back to community for them to go back and experiment and see if it works for them. I think that's what is kind of good for us. I think we need to build a community and share those thoughts, practices. Folks, on this session here, I hope you understand the value of being a part of a good community. Share your thoughts, take back the thoughts from other leaders who come on the sessions and learn from each other. I think that part of the future learning will never go away. I think, in spite of how many universities come, how many courses are introduced, how many frameworks come into picture, learning from each other will never go away. That will be a great future. So thank you, Nathan and Ayala, taking out time for us on your first day of the week, spending the time with us on your morning. Great to have you guys here, and I'm expecting that we will have a lot of requests for you, bringing you guys back in our session with the kind of response we are getting. So it will be great to have you guys again, and I look forward to that. Thank you, audience, for being here with us on a Sunday and making this session very interesting and interactive. We look forward to meeting you in our May session again with another interesting topic, another set of interesting communication and discussion with our other next topic leaders. So have a wonderful rest of the weekend, whatever is left, and stay safe, stay home, take care of yourselves, your family, and that's what matters right now. Thank you, guys.
Stay safe, everybody. Thank you very much for having us.